good day. So we will answer this question. To save time, I will not read this question. So first, we will input the given. So the given is the T1 is 25 degrees Celsius, the T2 is negative 35 degrees Celsius, the K1 is 0.04 watts per meter Kelvin, the K2 is 0.1 watts per meter Kelvin, and the heat is 10 watts per meter cube. And the temperature surface mass below zero, not equal or below 0 degrees Celsius, and the T outside mass below 22 degrees Celsius. So the required is the thicknesses of both material and the convection coefficient. So here the illustration, you can see inside is negative 35 and the outside is 25. And for the solution, we will use the formula Q is equals to delta T over resistance. And to get the resistance, it is simply L over Ka. So the first material is the thickness L1 is equals to 0.04 times 0 minus negative 35 Kelvin over 10. So the answer is 0.14 meters. So crush out na nato siya. Then next is the second material, which is L2 is equals to 0.1 times 22 minus 0 Kelvin over 10 is equals to 0.22 meter. And to find the convection coefficient, the formula is Q is equals to HA delta T. So we will find the convection coefficient. So H is equals to Q over area times delta T. So 10 over 25 minus 22 is simply 3.33 watts per meter cube Kelvin. So for the next problem, I will not read the question again. So let's proceed to the given. The steel plate, we have the thickness of 20 mm or simply 0.02 m. The conductivity is 45 watts per meter Kelvin. So that's the conductivity of the steel plate. Next, the mineral wool, the third material, which is the thickness is 0.2 meter and the conductivity is 0.05 watts per meter Kelvin. Next is the brick or the fourth material with thickness 0.7 meter and the conductivity of 0.39. And lastly, the second material is insulation brick with 0.5 thickness and 0.39 conductivity. Also, we have the T1 650 degrees Celsius and T2 35 degrees Celsius, and H1 is 65 watts per meter squared Kelvin and H2 15 watts per meter squared Kelvin. So the required is heat loss and interface temperature and temperature gradient. So the illustration here is we have the first, second, third, and fourth materials with its thickness and the inside and outside temperature and convection coefficient. Convection coefficient. So the solution is, the formula we will use is Q over delta I. So the formula we will use is Q equals to delta T over total resistance. So here, 650 minus 35 over 1 over 65 plus 0.02 over 45 plus 0.5 over 0.39 plus 0.2 over 0.05 plus 0.7 over 0.39 plus 1 over 1 over 15. So that is simply the total of the resistance of the from inside to outside. Next, the answer is 85.9 watts per meter squared. So the next question is the interface temperature. So the formula is the formula is the same. Q is equals to delta T over RT. And now we will find the interface temperature of the inside. So simply the heat is 85 times 9 times its resistance, which is 1 over 65. And then the answer is 1 over 32 degrees Celsius. And ato i-minus sa first nga temperature, which is 650. That's why sa inside nga temperature, ang interface temperature is 648.68 degrees Celsius. Next is the first material, which is steel. Same, ato ra gyapon ni times ang heat and its resistance. Then i-minus siya sa previous nga interface temperature, which is 648.68. So nahimo na siya 648.64. Next, same process. From 648 to 0.64, nahimo na siya 538.51. Next, same mo gihapon, nahimo na siya 194.91. And sa brick, sa fourth material, nahimo nag 40.73. And sa outside, which is 35 degrees Celsius. Next is the temperature gradient. So, ang formula is Q is equals to negative K area times dt over dx. So, sa steel, natay negative 85.9 over 45, which is ang 45 ang iyang conductivity. Ang answer is negative 1.91 Celsius over meter. So, crash out na itong unit. So, same na sad sa second nga material, ang ang insulation break. So, answer is negative 220.26 Celsius per meter. And sa third nga material, which is the mineral wool, answer is negative 1,718 degrees Celsius per meter. And sa last nga material, which is ang brick, ang answer is negative 220.26 degrees Celsius per meter.